So this is passage 2. This passage is a data passage. You're quickly looking at the scene, trying to understand what goes on, what are the variables, and then getting immediately to the questions. So think 15 seconds and then to the questions. You're going to quickly glance at it. It has a periodic table, has a figure 1, which has, it looks like aluminum, magnesium, groups, has elements, atomic numbers, density, heat, thermal conductivity, and some definitions. That's it. Then you're straight to the questions. Based on table 1 among the group 2A elements, as atomic mass increases, specific heat does what? So we see atomic mass, group 2A, atomic mass and specific heat. So atomic mass increases, so it goes top to bottom. Make sure you go in the correct order. What happens to specific heat? It decreases, right? So it's getting smaller. As these get bigger, these get smaller. So your answer is decreases only. Just be sure you pay attention to the direction as your arrows are going. It's always good to articulate as atomic mass increases, specific heat decreases. According to table 1, the specific heat of indium is closest in value to the specific heat of which the following elements. So there's indium, the specific heat at 298 Kelvin. We can look at these other elements and just circle those. So we have, now we're going to say it's closest to what? So 233 is closest to 0.204, so that would be barium, so A. Based on the definition of thermal conductivity and table 1, does strontium or thallium conduct heat more effectively at 298? So let's just make these bigger. And it says thermal conductivity, the ability to conduct heat, the greater the thermal conductivity, the more effectively the substance conducts heat. So greater conductivity equals more effective. So then we got to say, okay, we're looking at strontium and thallium. And we got to say which one conducts heat more effectively. Okay, so thermal conductivity is what we're looking. So thallium is 46.1 and strontium is 35.3. So based on our definition, thallium should conduct heat better. So we could go ahead and eliminate choice F and G. And now we're going to say why. The thermal conductivity of thallium is greater than that of strontium. So choice H is correct. Neither table figure 1, so we're looking at both these, is the thermal conductivity of magnesium at which the following temperatures. So let's start with 298 in the table. So it does give the thermal conductivity of magnesium there. So D is out, so it does give it. Now we look over at figure 1, we see thermal conductivity, and then we see, let's start with 50. So we can see where magnesium is at 50, and we can see it at 98, but we can't see it at 200. 200 will be, way out here somewhere that we can't see at the moment. So our answer has to be C. Neither table 1 nor figure 1 gives the thermal conductivity of magnesium at 200 Kelvin. Based on figure 1, so make sure at figure 1, put your finger on it. At which of the following temperatures is the thermal conductivity of aluminum, or it doesn't even matter if you know that's aluminum, Al, closest to the value to the thermal conductivity of magnesium? One of these two closest together. So at 10, they're pretty good ways apart. 30, they're pretty good ways apart. 50, they're a little closer. But when we get down to 80, they're pretty much touching. So your answer has to be J. It's a pretty easy question. This one's mostly a knowledge question, just interpreting the data. So what is the meaning of the value for density of indium given in table 1? So we're looking at density, and so it's going to be each centimeter cubed has a mass of 7.31. The numbers don't really matter. They're the same ones. You just got to understand that the centimeter cubed has a mass, not volume, and you're looking at the centimeters cubed, not grams. It even gives you a little hint right here. So, okay.